Everybody, I'm speaking. Right. Hi, welcome. Happy to see you all here. Good turnout tonight. Thank you for coming down. Tonight we've got two speakers all the way from Berlin. Yeah, so tonight we're going to have Miguel talking to us about Flutter and Firestore. Miguel is a freelance Flutter developer over in Berlin. He also offers training, so if you want to get in touch with him regarding that, feel free to get in touch with me or himself. And I'm going to let him carry on with his presentation. All right, thank you.
Thank you. Hey everyone, I'm Miguel. I'm a freelance software developer, as you said. I'm based in Berlin, and this is my first time I'm giving a talk in London, and also the first time I'm attending this meetup here. I'm very happy to be here, and also thanks to our sponsors who paid my flight to fly me here also. And as you said, I'm currently working on a Flutter project. Well, I'm working on two Flutter projects, and one of them is using Firestore. So my talk today is going to be about my experience integrating Firestore with Flutter on a real-world scenario with like real users and real use cases. And the code that I will be showing today, the sample code, is available on my Twitter account. Also, the slides are available on my Twitter account. So if you're this kind of person who wants to take the laptop off and start looking at the code, so you can do that already. You don't have to wait till the end. So why is this talk necessary? And first and foremost, because Firestore is actually pretty cool. Being able to build an app at the same time that you're building your backend without having to wait for your backend team to deliver all the things that you need is really, really fast. And also you get things for free like caching and offline support and real-time changes also as well, listening for the database and listening for the backend. So it's truly amazing what you can do with it in a really, really short time. But also the reason I wanted to talk about this is because now I'm facing what it's like to build a real-world project with it. And don't get me wrong, because sample projects are great and I use them to start learning how to use it, but then I faced some things that I needed to rewrite. And besides that, when you go to the official documentation, you see that the documentation is available for PHP. It's not available for Dart. So my talk is also going to be an example for you of how to use this API. So Firestore, if you know it, is a cloud database offered by Firebase. They define it as a flexible, scalable, NoSQL cloud database to store and sync data for client and server-side development. So let me dissect that. It is flexible because you don't need to define a scheme for it. If you need to add a property to a document that you have, you can just do that. You don't need to change the other documents that you have. It is scalable because it's in Firestore. And the fact that it's defined with documents and collections means that you can even split your database across different regions, so you don't need to have one single instance somewhere. You actually can have multiple instances of your database split across the world. NoSQL means that it's not a relational database. So you don't have joins and foreign keys like you will have in a SQL database. Cloud, because it's hosted in Firebase, it's not run locally, and sync data because it's actually a database that is synchronized across all your clients. And yes, that also includes server-side clients. So you can have a client which is a Node.js app. I said before, documents and collections. And what does that mean? So think as a document as a JSON file, which contains some kind of data. And that can be accessed using a key, and then you obtain a value. It's really like a map. Documents live in what is called a collection. And a collection is nothing more than a group of documents. In this example, you can see a collection of channels, like in a messaging app, and each document corresponds to one channel in the system, in the application. In Firestore, collections and documents are accessible using paths. For example, you can have a collection of users in the path /users, a collection of channels in the path /channels. Each document inside is also identified by an ID. So you can have the user document Miguel in the path users Miguel, or the document general in the path /channels/general. If you wanted to have messages of a channel inside another collection, you will use what is called a subcollection. And a subcollection is like a collection that belongs to a document. So to store all the messages from a channel, we will use a subcollection located inside one of these documents. And the path will be something like channels/channel ID/messages. I really like this way of structuring data because it tells me what's the context of the data that I'm using to. In this case, if I have a message which is in the path inside the general, I know that it belongs to general. So in this case, I have the path channels, general, messages, 1, 2, 3. It clearly tells me that this message belongs to this other collection and it is this other document. Why will you not have a top-level collection instead of using a sub-collection? Think like having a top-level collection of messages, and then you will have an ID that will say this message belongs to this channel. Well, actually, it depends. It depends on your use case, and the documentation doesn't say that you should do one thing or the other. It actually depends on what works best for you. Before going into reading and writing documents in Flutter, I'd like to add that there are many ways of accessing data in Firestore. You can read once a document given a path. You can read once a collection of documents also given a path. You can read continuously for updates. So you will get all the updates that happen in a document. And also as well, you can read collections, and you will get the full collection each time there is a change inside one of the documents of this collection. So let's see how you do that with Flutter. Now that we have the basics,
Can you read the updates for sub-collection?
No. So you need to listen these sub-collections separately.
Okay.
So you listen for your document, and then you need to set like a listener for the sub-collection also.
Okay.
Yeah, you don't get it for free. You need to do that. So to show you how it works, I will be showing you a sample app today that I created for this talk. I was a bit tired of to-do apps, so I created what is called a GIF review app. This app allows me to set ratings to GIFs, and I can select one GIF, I open the screen, and then I can tap on to set my score. You can see that the scores are also updated down there, and also if you go back, you also get the result of the ratings. This app uses Firestore, of course, and the database is structured in this way. GIFs are stored inside the GIFs path in the root of the database. And to access a GIF, I go to the path GIFs/the GIF ID. Ratings are stored as a sub-collection of a GIF. So every GIF will have a sub-collection of ratings that I will access with GIFs, GIF ID, and then ratings. And then my rating is going to be identified by my user, so it will be under GIFs, GIFs ID, ratings, Miguel. When you go to Firestore, you can actually visualize your database. And probably from the end, you will not see it really well. But what we have here is the top level collection of GIFs. Then we have the 3 different GIFs that you saw on the app. And these IDs are being generated automatically by Firestore. And then we have here the sub-collection for one of them. So I have selected the first one, and then I have a sub-collection here, and then I have a field on this GIF that I have here. And this field, for example, is just the URL. If I select this sub-collection of ratings, then I have, again, a list of documents, and you can find here my rating, and you can see that I set a rating of 5.0 to that previous GIF. So one cool thing about Firestore is that you can see changes going live in Firestore in the Firebase console. So I have here running the app on my device, and also at the same time I have the window open of Firestore, and you can see that every time I change here this score, this also gets updated and even does some little fade animation of colors. So it's clearly telling you that there was a change there. So I think that's really cool. That helps a lot debugging things. The app is just that. If you want to check the code, you can find the repo on my GitHub account inside Flutter London Firestore, and also on my Twitter. I will put the link at the end also of the talk, but you will find it on my Twitter. So this is a Flutter talk. Let's talk about Flutter finally. There was introduction on Firestore. Get deep into the code, and we will see the code of this sample app for learning. So accessing documents in Firestore is very easy. The first thing you need to do is, of course, the Firebase setup, which probably you already have done many times. If not, there is a setup page for Flutter specifically, so you have to follow the steps for iOS and for Android. And once you have that running and you're sure that Firebase is running correctly, then you can just access to the Firestore instance by firestore.instance. Super easy. Firestore has two important methods: collection and documents. And you can probably guess what they already do. They both get a path and they both return a reference to something. One returns a reference, a collection reference, and the other a document reference. With this reference, you don't have yet the document, you actually need to request it from this reference. So to read a document, we need to do an async call using the get method. So we need to do a wait here, and then do a get, or you will do a then if you don't want to use async await. And this returns what is called a document snapshot. Also interesting is that get accepts a source where you can say, I want to get data only from online, or I want to get data only from my device. And be careful, because if you select server to be sure about it, it will throw an exception if your device is not online. The other way, if your device is not online, you will always get the cache. So be careful about changing that. Once we have the document snapshot, we can read values from it. And we will access the values simply by accessing the properties, like if we will be accessing a map. So you remember that I had a rating in my document in the previous example. So here I can just read the rating. The thing is that if I call get to a document that does not exist, that works. But as soon as I call to get the field, that will crash. They will throw an exception. So it's good to always check if a document exists, just as a good practice. Let's see an example of this. So you saw the app before. And what I want to do is, when I open this screen here, I want to load the first value that I had before stored on the database for my score. The way I will do that is, first I get the path, and I have an utility method for getting the full path that I need for my rating. Then I get the document from Firestore. If the document does not exist, then I return 0. And then I try to parse the document here. And I will explain later why I'm doing this, but I try to parse the document, and if I fail to parse it, then I also give a 0. I also want to set my rating when I tap this rating stars widget. So tapping on the 5th should put a 5 back into the database. For that, I have to create a document if it does not exist. But instead of calling get, I will have to call to set data. Inside set data, we can pass the data directly just as a map, as you can see here. And that just contains a map of key and value. And you can have a complex map. It doesn't have to be like a one-level map, but it can be a really, really complex map. And even you can have arrays and similar things inside. This also returns a future void. So even if you're doing a set data and you are not interested in the results, you still need to do an await call here. Alternatively, you can also create a new document inside a collection by using the add method. The difference is that previously, I know the path that I want to create my document. So I know that it will be inside ratings Miguel at the end. Here, I'm passing the collection of ratings and I'm saying, just create a document for me, give it a random ID, what I'm doing with add. And in this case, I'm also passing here the payload that I want to put. And probably you're not getting void here, probably this is a mistake. You're getting the actual document reference because you need the new generated ID. You probably have noticed that I have this method called getPathRating in my previous example. And that's my preferred way of organizing paths. I will have a class that will contain all the Firestore paths that I have on my app. So I will have a method that will give me the path to the rating given a GIF ID and given a user ID. And then the paths, I will have them also here accessible for my app. So you don't want to start hard coding this into your app because it can become really messy. Like you're missing an S, for example, in one side of the app. You're not going to notice that until a QA comes up and says like, oh, this is not working.
Is it on purpose that you are missing slash between ID and path ratings?
It is on purpose because path gifs already have a 1. So then you need to separate every item with a slash. So I have the slashes here. I could remove the slashes from here and I could put them here.
Okay, yeah. Okay.
So the thing is, every item needs to be separated with a slash.
Yeah.
Yeah, good point. That was for single documents. So let's see how we can read collections of documents. Here, when we start the app, we get the collection of GIFs. So for that, what I will have to do is to get the collection. I just have the path here so you can see it. And then I call to get documents. And this get documents is giving me a query, it's called query snapshot. So before it was a document snapshot, now it's a query snapshot, which contains the list of document snapshots that we actually want. Then what I do usually is I map these documents into the actual Dart object that I need for my app. So I will run a map over the documents that I have inside this snapshot, and then I use this, for example, from.doc method, which takes a document and then returns an actual Dart object. One problem that I faced is that sometimes you get a collection and then you want to do another asynchronous call with each one of the items because, for example, you need to go into a sub-collection and get something. In my case, for example, I was loading the GIFs and then I needed to go into the sub-collection of ratings, get all the ratings, sum them together, and then calculate the average. So I had to do another asynchronous call inside this mapping method. And I didn't know that, but in Dart, so I'm sharing this with you, you can do a future wait, and then you can do a synchronous map inside. And this is very useful when you need to do asynchronous calls inside a map. So here I can do then an await for getScore. And getScore is also an asynchronous method that is giving me the rating for that, that individual rating there. And then with the rating and the document, I can calculate, I can do the final object here. You will have these kind of cases all the time when you start building big things that require data from different places to create objects. To easily map from document snapshots to the domain model class that I'm using, I always create from.doc methods. And these are very useful later for testing, you will see. Also here, you can notice this document ID. This document ID references to the actual document reference ID that you see in the path. So for example, if the document was inside GIFs 123, the document ID is going to be 123. So here you can generate, I use these methods always for parsing from document to GIFs. And then I have an equivalent method that will parse from a real object, let's say, to the map that I will be end up putting on Firestore. So far we have seen how to read and write documents and how to obtain a collection. To read a document, we will use documentpath.get. To write a document instead, we will be with set data if we know the ID, or at if we want to create a new document. And to obtain a collection, we will use collection, the path, and then get documents. Excuse me. So previously we learned how to read data once, and now we will see how we can read data continuously and get updates from our database. In my case, when I want to show this updated here live, so I want to be able to click on here and then immediately update also my value here. The way I'm doing that is by listening on changes on all the ratings for this GIF. The way to obtain this continuous subscription is by using the snapshots method. This snapshot method now is returning you a stream of query snapshots. Maybe you remember before it was a feature of query snapshots, so it was just returning one asynchronously. Here is now returning you a stream of different query snapshots. And you can do the same thing. So you can now map them from the snapshots to the actual document that you need to have. In this case, you see that you have two maps here. No? So you have one map for every single snapshot that you get, so for all the documents, and then you need to map individually each one of the documents that you have into the actual objects. So you end up doing these kind of things all the time when you're working with Firestore. Here with streams, you have the async map, which also facilitates having more asynchronous calls inside your mapping methods. So it's also helpful. This is very helpful. Sorry, yes?
Sorry. You were returning snap, back one slide again if you don't mind?
Yeah.
Yes. Return snap.documents.map from . What's that returning the map to?
Yeah, so this map here is returning a document snapshot into a GIF document, for example.
Yeah.
And this map here is actually giving me an iterable of GIFs. So I can add here a to list, for example, if you want to have lists. But this is at the end, this is an iterable of, no, sorry, it's a stream of iterable of GIFs, exactly.
Gotcha, okay.
Yeah, and so you subscribe to this, and then you get this list of GIFs all the time, continuously,
okay.
every time there is an update.
Thank you.
Good question. This is essentially the bread and butter of using Firestore with Flutter. So it's essentially pretty much what you will end up using all the time. But now let's see some real world lessons also. The way I like to organize my code is by using the repository pattern. Repository is just a class that exposes the access to all the data contained in Firestore, but doesn't expose any of the implementation details. Why you do that, doesn't matter which state management you are using. You should always do this. So for example, don't call to your Firestore directly from your middleware if you're using Redux. And I would like to give you two key reasons for that. The first one, because testing is really hard. Testing Firestore is complicated. You will see why. And second, because you also want this to be easy to replace. And why easy to replace? Well, you need to be careful with the usage quota. And the thing is that Firestore, you end up paying more or less by the amount of reads and writes that you do. And if your app just escalates heavily, you will probably want to replace your repository that you have in your app. So having a clearly separation between one and the other is very important from the very beginning, even if you're just trying out. Another gotcha that I saw is that data sometimes is not super stable. And you will see this example here with the ratings that I was showing before. I had problems, this is a double. And sometimes I had problems saying that they cannot convert from an integer to a double or from a double into an integer. And I don't know if the problem is on the platform implementation, let's say on the Dart level, or is a problem in Firestore. But I found that it's easier for me to just store strings. If you don't need to do queries later, it's easier for me to just store strings and then try to parse. This will throw an exception if it fails, or use try parse, which returns null, and then you give a default value. You have to practice what is called defensive programming. And even on the official videos from Firestore, there is a YouTube channel that has like 10 videos for Firestore. I really recommend you to watch them, at least half of them, because they are very, very good explaining everything. They advocate, use defensive programming. So don't trust that the database is going to be perfect, because you're going to be developing things, you're going to be changing documents, and that will mess up things up. So what we do is we recover from database errors by essentially first filtering data which is not good. So we have, before our from doc methods, we check if something is missing, like, oh, we added this field, so all the documents that didn't have this field, we're not going to use them anymore. So we filter them out. Also, we use the try parse methods a lot together with default values. So let's say a rating maybe is lost in this case because we did a change in our database. That will be fine. So you need to be careful about that and about this kind of problems with data. Talking about unit testing, let's see how we can do that. And the first thing that I tried is say, okay, I want to test absolutely everything. I want to test my repository. And then I started mocking things, and then I said, okay, I need to mock Firestore. Then this Firestore returns a document. I need to mock document reference, and I need to mock document snapshot. And we had also query snapshot, and we have something else. You start mocking lots of things, it's impossible. So what we did was just to focus on our from doc and to doc methods in our repo, which were the important ones at the end, the ones that get the data, that parse the data, and then they set the data back. And a way to do that in this example is very simple. So I have to mock document snapshot. This is the important one. And then with my mock, I will say, when I request a URL, return this URL. When I request the document ID also, return this ID. And then I can test my from doc method, which is exposed as a static method. And I can compare what I was expecting with what I got here. If your repository has lots of features, you're probably going to be returning features from your repo. You can also test them easily using the synchronous feature class here. So you will create a mock for your repo, and then you will say, when I'm requesting gifts, then answer. You see that we are not using then return here, we're using then answer because it's an asynchronous method. And then you will use synchronous feature to actually return some mock data here for your test. With streams, it's similar. You use what is called a stream controller. So with a stream controller, you can have the list of ratings here, and importantly, you need to set sync to see true, because then when you're testing, you want this stream to go on the same thread. Then you will return the controller stream. So from the stream controller, you will return the stream when you are requesting the ratings on your tests. And finally, later, you can add the ratings just to see how it's reacting to the data that you are passing. Perhaps the most annoying problem of Firestore is build times. And this was shared also by Martin from Code Magic last week, a couple of weeks ago in Berlin. He exposed that when you have Firestore in your project and you try to build for iOS, it can multiply, I don't know, 20 times is this. So a lot. This is almost 40 minutes. So it will take super long to build when you have Firestore. So keep that in mind. No, don't panic when you do that, because everyone is going through this. We are going through this also. Before the end, I want to give some words about using Firestore together with Redux, because that's what we do. We use Redux in our app. So we found that some things work really well with Redux, some things don't work as we thought they will. So this will be some tips if you're using Redux or if you need to decide which state management you're going to use together with Firestore. The way I will define my middleware, sorry, you need to be a little bit familiar with Redux. So in Redux you have something which is called the middleware, and in my middleware I will pass the GIF repository or any repository that is accessing to Firestore, and then I will use it in my actions here, in my reducers of the middleware. And in this case, the load GIFs, what I have is I'm passing the repo, and then I'm requesting the list of GIFs, for example, and this goes into Firestore normally. So I get my response, and then I dispatch an action back that says, hey, I got my response from Firestore, so now you can update the app state with it. Reading a single document is easy, or reading a collection, let's say. So you request the document, and then when it's loaded, you give another action to store it. But what happens when you actually want to subscribe to a stream, and you're not going to be getting one single thing, but you are going to be getting a stream back? And that place, we realized that Redux was not the best idea, and you will see why. What we're doing now is this, and you maybe have better ideas. I would love to hear them. So maybe after the talk you can find me and say, oh, I have a better idea for you. So what we do is this. We subscribe, and then every time we get a new, so we subscribe doing a listen to the list of ratings. Now remember that this was returning us a stream of ratings. So we listen to it, and every time we get some data, we are gonna dispatch this action on update ratings action, which is updating our app state. But also at the same time, we have a subscription, and this subscription, I'm gonna store it also on the app state. So we're gonna have this subscription in the app state. And why I need to store this subscription in the app state is because I want to unsubscribe later. So in this case, for example, in the GIF review widget, I will have the dispose method, and in the dispose method, I will dispatch an unsubscribe action that will go into the app state and then will close this or cancel this subscription that I have. So this is, for example, inside the middleware, inside the unsubscribe action, I will go into the state and will say, okay, cancel this subscription that I have here. And personally, I'm not happy with this, but it works. So, well, maybe better is to use block, because block is made in mind with the streams. So in block, you already have a dispose method that you can use for canceling ongoing streams. Or even better, you can use the streams builder widget from Flutter, which you already can get a stream, and this stream builder takes care of subscribing and unsubscribing when the widget is being disposed. So I'd like to hear some opinions from you. Quick recap at the end about the most important things here. Data is structured in Firestore using documents and collections, and you need to understand this difference, and you need to understand well how they work. You use paths to access both the documents and these collections. You can read data once, and you will get it as a feature, or you can read data continuously and you get it as a stream. In both cases, they are classes that exist in Flutter, they exist in Dart, and you can use them easily. You can store data in documents also, and I recommend you to use always a repository pattern when you are working with Firestore. Do not try to mock Firestore when you are testing, and instead focus on your mapping methods and check that they are fully tested with a happy and unhappy path. And when using Redux, keep in mind what you're going to do with the streams. Don't subscribe and just leave your subscription there. You need to unsubscribe later. Thanks a lot to everyone. I hope that you have learned something today. And please check the source code. Please check the slides again if you need. And I'm happy to chat with you. Thank you.
So I'll be posting up his link to his source on the Twitter later.